Good afternoon. My name is Leah, and today I'll be walking you through business data analysis. Over the next few minutes, I'll share how I approached this in my Jupyter Notebook, the methodologies that I followed, and the insights that I uncovered through this data. Today, we'll take a look at the context and goals of the project, the target audience, the 5 phases of data visualization, and key takeaways from the data visualization. For context, businesses rely heavily on insights from historical data to remain competitive and to effectively advertise to their customers. Businesses can directly influence their customer engagement by choosing marketing strategies that align with what has worked for them historically in driving their revenue. This analysis aims to explore key business questions using a structured data analysis workflow defined by Murak et al. Leveraging historical performance data, a business can refine its marketing strategies, optimize spending, and guide decision-making for greater future success. A successful data analysis has many key components. For instance, we'll want to set our goals, define our audience, get the data, clean the data, prepare the data for the analysis, actually analyze the data, and then provide a visualization of that data. There are many different types of questions we could ask in our data analysis. Some of the questions might include how profitable are the product categories, defined by return on investment? Are customers more likely to be in a higher subscription tier given a higher subscription length? How does advertising budget impact customer engagement across campaigns? And so on. We'll go into each one of these questions in detail throughout the analysis. For this project, my target audience was business managers, shareholders and stakeholders, and C-level executives. Understanding these data-driven approaches is essential for evaluating market opportunities, assessing risk, and ensuring sustainable returns. Next, we'll go over the 5 phases of data analysis and visualization. The first step in the process is to get the data. My data was sourced from a GitHub repository and had a CSV format. I used the marketing and product performance dataset. The dataset contained 17 columns and 10,000 rows. With CSV files, it's generally a straightforward process. The complexity of the columns or the features emphasize to me just how necessary it is to have domain-specific knowledge. It's important to note whether the data are real or simulated. Here it is simulated, but this data closely reflects real-world scenarios. To the right, you can see a sample of the different column names. In the next phase, we want to clean the data. This involves removing unnecessary columns, addressing outliers, and addressing null values. Real-world data is typically dirty. This is where the first modifications will happen to the data frame. It's often needed to manage real-world data. This step ensures that the data frame is complete, valid, and able to be processed later on in the data analysis. The third step of the data analysis involves preparing the data. The goal of preparing the data is to make it suitable for data analysis. In this phase, I might want to add columns derived from other columns, shape the data into other forms, or make preliminary data visualizations for better comprehension. The goal of preparing the data is to transform a clean dataset into a form that maximizes its utility for analysis and modeling. In the fourth phase of the data analysis process, I will group and aggregate the data, make preliminary visualizations, and work towards modeling the data. This is the core of the process, where patterns start to emerge and where hypotheses might take shape. Aggregations help reduce noise and spotlight variation across meaningful groupings. This is where I can begin to answer some of those preliminary questions about the data. In the fifth and final phase, I will visualize the data. This is where a visual is made, and from it I can shape a story. This is where we can transform the raw data into a form that resonates with both technical and non-technical audiences, whether they are shareholders or a general population. The right visualization can illuminate patterns, emphasize key takeaways, and guide decision-making for executives and beyond. Now let's dive in and take a look at the Jupyter Notebook, which contains my full analysis and a breakdown of all of the steps. Now we can go over the project in detail. For this project, I used the Pandas, Numpy, Seaborn, and Matplotlib libraries. I used the marketing and product performance dataset, which is linked in the description here. Once again, it contains 10,000 rows and 17 columns. The columns contain a lot of valuable information, such as the clicks, conversions, return on investment, customer ID, subscription tier, and so forth. When I was getting data for this project, I initially had a hard time telling the difference between simulated and real data, and sometimes it's not very obvious which is which, so you really have to do some digging when you're picking which data to use. Also, in my case, I used a CSV, which is a relatively straightforward process. The complexity of these columns really emphasized to me how necessary it is to have domain-specific knowledge in what you're working with. This can give you greater insight and provide a framework to work from when you're trying to figure out which way you want to display the data. For this project, I had many goals. I wanted to generate actionable insights by addressing some business questions. These questions spanned areas such as the profitability, the customer's behavior, marketing effectiveness, and product performance. Taken all together, the goal of this analysis is to inform smarter decision-making and to offer informed growth opportunities by providing insight into how revenue relates to the advertising decisions of the company. As an outline for this analysis, I decided to focus on 6 main questions. First of which is, how profitable are the product categories defined by return on investment? Are customers more likely to be in a higher subscription tier given a higher subscription length? How does advertising budget impact customer engagement across campaigns? How does return on investment vary across different subscription tiers and discount levels? How does revenue generated change over subscription length for each subscription tier? And what are some common keywords most associated with high-performing products? My target audience was the shareholders, stakeholders, and C-level executives of the business. And now we'll get into the first phase of data analysis. So first of all, I'll need to import some modules. So I imported them here. And I imported the data and loaded it into a Pandas data frame, which I called mapdf, which was an abbreviation for the name of the CSV. I then took a look at the head of the data using the head and looked at the tail. Next, I took a look at the shape, and this confirmed once again that I'm working with 10,000 rows and 17 columns. I looked at the data types and determined if they were containing any easily spotted missing values. I saw 10,000 non-null values for each column, which suggests that there are no missing values. And then the data types themselves appeared suitable for what the column contained. So for instance, there were objects for string columns and integers or floats for numerical columns. I took a look at a concise list of the column names, and this helped me to form the questions that you saw above. I then described the data, which gave a sense of the scope of the data and helped me to identify any initial problems. And I could see that all the columns once again had no missing data, given that the counts were all 10,000. So for the next phase, I cleaned the data. And to do that, I dropped some unnecessary columns and checked the resulting data frame. Since I won't be analyzing the bundles, they will not be needed, so I dropped both the bundle ID and the bundle price columns. I then verified that there are no null values and none appear present. All columns produce 0 when I summed up the nulls. I then took a look at if there were any duplicates, and this gives me a clear visual report of the presence of duplicates. And then just to extra verify that, I chose to use value counts on duplicated and found false for every one of the 10,000 rows. So that's what that's telling me here. So I feel pretty confident that I have no duplicates and my data is pretty clean and ready for preparation. Next, I will prepare the data. And the goal of preparing the data is to make it suitable for data analysis. So to do that, I first took a look and made some preliminary investigations. This kind of helps to bring the data to life. At this point, I can detect distributions, outliers, potential correlations, and these visuals kind of help me form hypotheses. They give me some hints about potential relationships that I might want to investigate. This step really helps with making the data set into a structure that our tools later on will receive very well. So Matplotlib and Seaborn, you may need the data to be adjusted a little bit so that they'll be able to receive that input. And so that's what we'll do here. So first of all, I created a budget histoplot and clicks versus conversion scatter plot, return on investment by subscription tier, box plot, and a correlation heat map for numerical features, a heat map. So this is what they ended up looking like. The distribution here you can see is relatively uniform. For the clicks versus conversions, it was kind of all over the place, so it's a little hard to see some trends in this format. The return on investment by subscription tier seemed pretty uniform for premium tier, basic tier, and the standard tier. And then taking a look at the correlation heat map, I didn't see any clear trends really pop out at me. This is all very uniform in this heat map, so it will give me a sense that the data will need to be prepared a little bit more, and that will help us to uncover some of those relationships that might be hidden. So to address the first question, I am preparing the data in a special way. First, I define the product categories column, and this product categories column slices off the prefix from each of the product IDs in the columns, which is 5 characters long. So that's what this strip is doing here. It's just taking the PROD_ prefix off of each item in the product ID column. And then it stores the remainder in a new column called product category, which is defined here. And this is kind of a clean way to isolate the unique identifier for each of the product codes. I then defined some bins and labels. This defines thresholds for grouping the data. So the bins were defined here, and then the labels were defined below. So I defined a low return on investment as 0 to 3.99, a mid return on investment from 4 to 4.99, and then a high return on investment at 5. These could be defined by the business in particular. So instead of me defining it, there might be some business guidelines that I could use to determine what the label should be here. For illustration though, this is how I decided to group it. And then I created the tiered ROI column. This segments the continuous return on investment values into some labeled bins. And then this also adds the result to a new column called the return on investment tier. And that'll kind of make it easier to compare performance across those tiers later. So next I'm going to skip down to the next part of this first question, which was analyzing the data. So I was able to determine by grouping this that the vast majority of the total revenue is coming from initiatives or investments that have a pretty low return on investment. You can see that here. The investments with a high return contribute pretty little to the total revenue shown, as you can see here. And this could imply a strategy where a large volume of low return on investment activities are pursued, or that those opportunities are pretty rare or can't really be scaled up to generate a significant revenue. So let's take a look at what that actually looks like in a visual. So I'll skip down here. And I chose to use a bar plot for this. And this kind of helps uncover trends in a more user-friendly way. So I used the plt.figure to define the figure, and then defined the bar plot using data from the return on investment tier summary, and then added the value labels on top of the bars to kind of give you a greater sense of which tier produces what revenue. So clearly you can see a big difference between these. The low return on investment brings in the most money, $388 million, whereas the highest return on investment actually pulls in around $500,000. So a pretty big difference. And then next we'll address question 2. So question 2 was, are customers more likely to be in a higher subscription tier given a higher subscription length? So to prepare this, I defined the bins, and then the labels, 0 to 3 months, 4 to 6 months, 7 to 12, 13 to 24, and then 25 and over. And then for the analysis for this question, I found that by cutting the data, I was able to better create some insights. I was able to create a length bin column, which put a label on the subscription length, and then connected that to the subscription tier. And then I was able to have counts and percent breakdowns for that. So that helps to give a clearer visualization of what's happening based on the subscription length that the customer has been with the company. And I found that the basic subscription tier has the highest percentage of customers across all the subscription lengths, which indicates it might be the most popular or accessible option. Generally, the distribution of customers across the three tiers is pretty even. Each tier typically holds somewhere between 31 and 36% of the customers. The standard tier shows a slightly higher proportion of customers, suggesting it's a popular starting point for new subscribers or those who might just be trying out the service. And then as the subscription length increases, the basic tier tends to be the one people want to select. So it doesn't matter how long you've been with the company, you'll probably be wanting the basic subscription. And then we can see that in a visualization down below. And I chose, once again, to do a bar plot. And that really shows visually a lot more clearly what the data above was showing, where we have relatively even distribution, but as the subscription length increases, that gets even more close, and basic seems to overtake eventually. And next I'll address question 3, which was, how does advertising budget impact customer engagement across campaigns? So to prepare the data, I prevented dividing by 0 and then added a conversion rate column, which was just the conversions divided by the clicks. And then I also just double checked that those columns were in fact numeric, and they were. And then going down to the analysis for question 3, the resulting graph from this data had shown that for this data set, the advertising budget and the number of clicks generated were pretty widely scattered with no apparent direct correlation. While most advertising efforts had yielded a low conversion rate of about 15%, the higher conversion rates were rare and mostly occurred when the number of clicks generated was low. So overall, this could indicate that achieving high conversion rates on a large volume of clicks is challenging. Bottom line, a larger budget might not produce greater clicks or conversion rates. So the more you spend, there's no guarantee that you're going to get those clicks or conversion rates, which is important from a business perspective if finances are strained or if you're working within a budget. So to see this, we'll scroll down to the visualization for this third question. And I used a scatter plot to plot this. And you can see there's not really a clear correlation, there's not a clear linear relationship. The conversion rate was pretty standard across the whole thing at about 15. Down below we do see some larger conversion rates, but it's not super clear if that was situational or if it was random. So simply increasing or decreasing your advertising budget is not going to necessarily lead to a corresponding increase or decrease in clicks. And then going up to question 4, the preparation for that. So that question was, how does the return on investment vary across subscription tiers and discount levels? So first of all, I needed to reshape this data into a pivot table, and that makes it usable for a heat map. So that basically turned it into this form that you see here, with the different discount levels across the columns, and then the subscription tier as the rows. So I have basic, premium, and standard here. And then for the analysis for question 4, I found that different strategies could impact the profitability of various subscription tiers. The discount level of 19% was kind of problematic for the premium and standard. It consistently shows that the lowest return on investment for both the premium and standard tiers, which makes it a critical point to investigate. The discount level of 31% often performed pretty well. For all the 3 tiers, the 31% discount was kind of a sweet spot. It yielded high return on investment. There was not really an optimal discount level. The return on investment was not uniform across all the tiers. So for example, the basic tier also performed pretty well at 36% and the premium at 13%, but there doesn't really appear to be a universally bad discount. some discounts were worse for certain tiers, but there wasn't really one discount level that is universally bad across all of them. So to take a look at what this looks like, for question 4, I used the heat map, and you can really clearly see the trends a lot more clearly. We've got the color coding on the right here, and then the subscription tiers on the left, and the discount levels down below. So you can quickly reference this and go, okay, is a 10% discount generally performing better or worse than a basic tier with about the same discount? You can see that they're basically about the same, given that their colors are similar, the values are similar. We could take a look very clearly at, say, the standard tier at month 22. That it has an increased return on investment. The subscription tier premium at 19 months is actually pretty low, so that can kind of help guide your marketing efforts and help you emphasize certain tiers versus others, certain discount levels versus others, and help guide your customers towards those most ideal ranges. And then next, for question 5, we'll go up to the preparation for that. So for this question, I was asking, how does revenue generated change over the subscription length for each subscription tier? I didn't really need to prepare this data frame for this question, but I did analyze it a bit and shape it a little bit. So I'll go down to question 5. We can see here that I grouped by the subscription length and the subscription tier, and then I summed revenue generated. I then sorted by the subscription length for a clearer line graph, and then down below you can see the head of that data frame, the revenue by length tier. And that gives a fairly straightforward view of that, but the visualization will be a lot more clear. And for this question, I ended up discovering that the data shows no clear relationship. The performance of each tier varies a lot depending on the subscription duration. I think a business would probably need to analyze some specific peaks and troughs for each tier to better understand what might be driving those revenue changes. So like a dip might indicate where the customers are leaving the service or churning, while a peak might suggest a successful retention strategy or maybe a popular initial subscription. So to take a look at what that looks like visually, I'll come down here, and you can see I used the line plot to plot subscription length and revenue generated. And here's what that resulting graph looks like. You can see that it's broken down with a legend by basic, premium, and standard, and there's no clear relationships here. So this doesn't necessarily lead to a lot of insights, but it can kind of guide data collection for the future. And then I'll go back up to my last question, question 6. So to prepare that, I ended up defining some high-performing products based on the 75th percentile of revenue generated. My question had been, what common keywords are most associated with those high-performing products? So this portion here really helps to actually define that percentile. And then I filtered for the highest performing products, and then took a preliminary look at what that was. Here was the 75th percentile, so about $74,500. And then we can scroll down to the analysis for that. So it required a little bit of cleaning. I cleaned the common keywords and just made sure that there were no empty strings and filled any not a number values. I counted the frequency of each keyword using value counts, and then I removed any empty strings if it existed. I then got the most common keywords and then displayed those down below. So in this data set there turned out to be just 4 keywords, and they were, upon closer inspection, just listed by themselves. So some of this cleaning I didn't actually end up having to do, but I wanted to include it just for completion. So you can see down below there are only affordable, innovative, durable, and stylish used in the keyword column for all of the data in those 10,000 rows. So This gave kind of a breakdown of how common those keywords were. And then to analyze those, I put that in a bar plot. So you can see they're pretty frequently referenced, all of these, but the word stylish seemed to be the lowest priority in driving some high-performing products. So that kind of suggests that the customers are looking more for affordability, which was the most common keyword, and then the aesthetic appeal was their least important consideration when deciding to buy a product. So, to summarize the key takeaways, I learned a lot through this data visualization process, including how to find data, analyze its potential, import it, clean it, pre-process the data, and analyze business questions, and then finally visualize the answers to those questions in a more friendly way. And then it also emphasized setting goals and defining a target audience, which is a very important aspect of connecting people with information. It makes information a lot more approachable and easier to digest. And then after finishing this project, I'm a lot better poised to answer business questions and communicate insights. Thank you so much for joining me on this data analysis journey. I hope you learned a lot through this presentation and walk away with a great appreciation for the data visualization process. Take care.